We said because the numerators are the same, then it means our denominators are also going to be what? The same, okay? So which brings us to the point that, okay, this is where we got to, okay, this is a step we got to, which says 6x squared plus 5x minus 2 is equal to a into bracket x minus 1 times 2x plus 1 plus b times x times 2x plus 1 plus c x times x minus 1. And I was explaining that if we let x be equal to 1, okay, 1 minus 1 will be 0. So this whole term will go to what? 0. And then same here, when x is equals to 1, this will also be 0. So everything here will go to what? Will go to 0, which means we'll be left with the expression 6 times 1 squared, which is 1, okay, plus 5 times 1, which will be 5, minus what? 2, equals to b times 1 is b. Okay, so we are having b times 1, okay, times what? 2 times 1 is 2 plus 1 is 3. So we have 3 here. Okay, so we have 3. This side, the right hand side will give us 3b. Okay, and then the left hand side is going to be 6 plus 5 is 11 minus 2 is 9. So we have the equation 3b is equals to what? Is equals to 9 here. So we have 3b equals to 9. Now, if we divide both sides by 3, then it means that our b is going to be equal to what? Will be equal to 3. Okay, so that is the first solution. Then in the next solution, if we want to select the next x, okay, you look at it carefully. So let's see what we can to get either A or C. So another step we could take is to let x be equal to 0. Okay, because we have b times x here and c times x. If we make x equals to 0, then it means that b times 0 will be 0. So everything here will go toward 0. The same way, if this is 0, then everything here will go toward 0. Okay, good. So in our step 2, we let x be equal to 0. If x equals to 0, then the expression will become, so let me clean this side. So if x equals to 0, then we are going to have the expression, let me write it here. We'll have 6 times 0 squared, which will be 6 times 0, okay, plus 5 times 0, minus what? 2. We've already said that the terms a times 0 times 2 times 0 plus 1 will all go to 0. Sorry, bx, which is b times 0, will go to 0. Okay, this term goes to 0. This other term also goes to 0. So it will be left with what? Just the a term here. Okay, so this will now be a into bracket what? 0 minus 1 will be -1. Okay, times 0 will be 0 here, plus 1 will be 1. Okay, so we are going to get as minus a, okay, equals to, this is 0, this goes to 0, this is 0, this goes to 0, and we are left with what? -2 on the left hand side. Dividing through by -1, okay, will give us a equals to what? A equals to 2, positive 2. Okay, then for the very final one, we want to see the values of x, which we will select. If we should make x equals to, let me clean this side first. if we should make x equals to, say, negative half, okay, x equals to negative half, we found A, we found B, okay, so now we need to find C. And to find C, you see A and B both have common, okay, terms here, which is 2x plus 1 and then 2x. If we select x as negative half, okay, if x becomes negative half, then we are on this bracket here, okay, so 2 times negative half will be minus 1. Minus 1 plus 1 will be equal to what? 0. So if you let x be negative half, then this term will go to 0. It means A will also go to 0. The same thing to 2x plus 1 is the same term here. So if this is 0, this will also be 0. So it means B2 will go away. Then through that, we can solve for what? C. Okay. So let's see how that will go. So this will give us we are letting x be equal to, that's minus half is the same as negative 0.5. Okay, so in our expansion, let me clear the screen first. Yes, so in our expansion, we'll have 6 times minus half, okay, squared, plus 5 times half, 1/2, negative, okay, minus half times, no, minus 2, okay, equals to, like I said, this one goes to 0, this will go to 0, this also goes to what? 0, okay? Yeah, so it's left with the C term here. So we have C times what? Minus half, okay? Times what? If we times that, we don't have mass space there. But this term here is going to be minus half, okay, minus 1. Good. So please, I don't need you to write on the screen for me. Ricky, stop writing on my screen. Okay. So once we do that, this side will give us, the square will affect the half, okay? So we are going to get 6/4, which is 3/2, okay, plus minus what? 5/2 minus what? 2 equals to what? C times. Now we have minus half here, and then at this side too, we have negative 3/2, okay? So negative is positive, okay? And then 1/2 times 3/2 will be 3/4, okay? Good, which is 0.75. Then when we come here, the LCM here is what? Is 2, right? So we have 1/2 here, minus half will give us what? That should give us, when we subtract this from this, we get 1/2 here, okay, minus 2 is equals to what? 3/4, okay, C. Good. And then once we simplify this, half negative, so we are going to get half minus 2 will give us minus, okay, 3/2, which is 1/2, okay, is equals to 3/4 C, right? So solving for this, when we do the simplification, that should give us, we can multiply both sides by what? 4/3. You multiply this side by 4/3 and multiply this side too by what? Sorry, this side was 6/4, not 6/2. Okay, when we square the 1/2, it will give us 1/4. So that will be 6/4. So meaning that, let me clean that side and redo it. So meaning that when it comes here, LCM will be what? 4, will be 4. Then we have 6 minus 2 goes into 4, 2. Then multiplies the numerator will be 10. So that will be 6 minus 10 is -4. Divided by 4 will be -1. Okay. So -1 minus 2. Okay. So which will give us -3 on the left side. Good. So let me just write -3 there. So on the left side, we have -3 is equals to 3/4, okay, times C. And then solving for it, this is it over here. Okay, so when we solve for it, we are going to get C to be equals to -4. Okay, so once you obtain your -4, then we put it back into the original expression here. We know A is 2, B is 3, and then C is -4. So you put those factors back into the original expression. Let me clear the whole screen. Okay. So then we are saying that in that case, 6 squared plus 5x plus 5x minus 2, okay, over the denominator, which is x times x minus 1 times what? 2x plus 1, okay, is equals to what? A is 2, so that will be 2/x. B was 3, so we have 3/s minus 1. And then C was -4, so -4/2x minus 1. Okay, so that is for 3 linear terms. Now we want to move on to another type. If there's any question, you can ask before. Okay, so in the absence of questions, let's move on to another type of problem. Okay, so we are looking at case 2. Case 2, this time we have linear factors, but the linear factor is repeated, like you can see here. Okay, so this time it is what? It is repeated. So you took note of the square here does not make it a square. It is the same x minus. This simply means what? This simply means that it is x minus 5 times what? X minus 5. That is what it means. So the square means it is multiplying itself twice. Okay, so x minus 5 minus x minus 5. That is what it means. So let me clear the screen, and then we see the expansion of it. Good. So when you have a repeated, like we have, this is how you expand it. Okay, so you are going to have 3 terms, because like I just showed you, x minus 5 squared, it means x minus 5 times. So that is going to be 3 terms. Okay. So in expanding, you expand the first term will take x plus 1. Second term will take x minus 2. But the third term is going to take x minus 5 square. Okay, x minus 5 square. So you take note of that. Good. Now let's see the expansion for it. I've seen some hands raised up. You have to hold on first. Yeah, so we split this into partial fractions. In an example, the example we have here, let's clear our screen here. I wish we could even look at this first. So if we were to find this, it's still the same process, okay? You find the LCM and then keep going, right? So if we were to expand this, we'll begin by having what our LCM, which is what? Just a minute, I want to take this thing off. Just a minute, please. So, like I was saying, for repeated, okay, linear fraction, please, your video should go off. I don't know how many times I have to say this. So we have our denominator, which will be x plus 1. Okay. Then we have x minus 5 plus times what? X minus square. Okay, it follows the same process. Then in your numerator, you're going to ask how many times does this go here? Okay, and we follow the same procedure. That is what we are saying. So let me clear what we have here and then go to our. So in our example here, we are to express what? We are to express 11x squared plus 14x plus 5, okay, over x plus 1 squared times 2x plus 1, okay? Good. So we follow the same process. So this is going to be A, B, and C. Now for A and B, because we have x plus 1 squared, first term will be x plus 1, second term will be x plus 1 squared. Okay. Then for the LCM, you see already x plus 1 is in x plus 1 squared. Then we have 2x plus 1. So LCM will be x plus 1 squared times 2x plus 1. Okay. Then you ask yourself, how many times will x plus 1 go into x plus 1 squared times 2x plus 1? It's going to be x plus 1, okay, times what? 2x plus 1. 2x plus 1. That is the number of times this denominator will go into the resulting denominator here. Okay, so you use this to multiply your numerator, as you can see up here. Then when you are done, you come back and ask yourself the same question for the next what? Denominator. So for the denominator of B, you can see we already have x plus 1 square. So x1 plus 1 square will go into our LCM here. How many times? That will be 2x plus 1. So we use that to multiply what? The numerator. So that is why you have B times what? 2x plus 1. Then finally, denominator of C will go into these terms, this number of times, which is x plus 1 squared. So we use that to multiply C up here. Okay, good. So then the next stage is we know that the denominator here is equal to the denominator here. Okay, which means that the numerators will be the same. So then we can write the expression. Let me check if the expression is already there. So we can write this expression, okay, and use, first of all, let's try using our usual expression, usual method to eliminate, okay? So if that is the case, then the question is, can we make anything zero here, or can we eliminate any of the terms? Yes, we should be able to, because look, A has x plus 1, C also has x plus 1. You see, so if we let x be equals to 1, we can eliminate A and C to get what? B. Then again, A has 2x plus 1 here. B also has 2x plus 1. So if we can let x be negative half, negative half means 2 times half will be 1 minus 1. So that can be 0, and this can also be 0 for us to find what? C. Okay. So selecting what? A equals to minus 1, x equals to minus 1, and x equals to half, okay, are good options to help us to find B and C. Okay, good. So let's give it a try. I think I saw somebody's hand up. The person has lowered the hand. You can raise your hand up again if you have a question. Yes, Osman. Yes, Osman.
Also, like I was trying to help you with the number we are going to use.
Okay, Osman, thank you. Today, our time has been wasted a lot, so the participation is, but I'll give you time for questions as usual. Okay, so moving on, when we select s equals to minus 1, okay, the simplification has already been done though, but let's see how it was arrived at. I know you understand by now, but let's just be sure. So meaning that we are putting this one to be minus 1. Minus 1 plus 1 will be 0. So Salisu, please, you are writing on my screen. This will go to 0. And then the same, we have x plus 1 here. So if I put minus 1 here, minus 1 plus 1 is 0. So this whole term will go to what? 0. Okay. So then it means that we'll get 11. Let me write by the side. 11 times negative 1 squared will be 1 plus 14 times minus 1 will be minus 14. Okay, plus 5. Just a minute. Okay. So then on the right side, we have A is 0 now. So it's left with B. So B, we have minus 1 here. So that would be negative 2. So 2 times minus 1 is negative 2. Plus 1 will be negative 1. So we have minus 1B or minus B. Good. And on the left side, we have 11 minus 14, which is negative 3, plus 5, which will be 2, positive 2. So then we have minus B is equals to positive 2, and B should be equal to what? Negative 2. Okay. So moving on, I'm seeing 2 hands raised up. I'll give you time to ask questions, so just be patient, but you keep your hands up. So that is how we get what? B to be equal to what? Negative 2. Okay, now let's find for the next one. So here we are saying that if x is half, we've talked about a half already. So negative half, if we make x negative half, that will be 2 into bracket negative half, okay, plus 1 will always be equal to 0, because 2 times half will cancel 2. So you get minus 1. So this side will be minus 1 plus 1 will be 0. That is what is making a equals to 0. Okay. And the same way, because b also has the term 2x plus 1, this will also go to what? 0. So this time around, the only one that will be left will be c. Okay, because a is gone to 0 and b is also going to what? To 0. So let's do that calculation and see. So for c, we are going to get this time x is minus half. So we have 11 times what? 1 over 4. That's 1 over 2. Negative 1 over 2 squared will give us 1 over 4. Okay, plus once again we have minus, okay, minus half. So the negative will affect the 14. So you, for the meantime, let me write 14 times negative half, okay, plus 5 equals c into bracket what? Minus half plus 1. Negative half plus 1 will be what? Half. So I'm not going to write that step. So let me just write half here. So this is half. Half squared is also going to be 1 over 4. Okay, that is a half squared will be 1 over 2 squared will be 1 over 4. So this will give me 11 over 4. Okay, minus what? 14 over 2 is 7. So minus 7 plus what? Plus 5 equals to c over what? Over 4, right? Yeah, so from here, when we simplify, we should be able to get c. So let me, undo. So I'm going to clean this, just this side. Yeah, so that will be the final answer. C is equal to what? C will be equal to 3. Okay. So next, let's see if there is any other value we can make 0. No, we can, which will give us, which will help us to eliminate anything for us to get A. It looks like so far we are left with no other options. Okay. Now there are different approaches at this stage too, where you realize that there is no other option for you to subtract your maybe no other x value, okay, which will eliminate B and C. Good. When you get here, there are so many ways you can go about it. Now I'm going to show you one of the ways. And one way is what I have on my slide. So here, if I let s be equal to 0, okay, this is what I'm going to get. I'm going to get this equation. So if x equals to 0, when I put 11 times 0 is 0. 14 times 0 is 0. So I'll get 5 on the left side. Then if I make this 0, this x is 0. So, and then this side will be 0. So that will be a times 1 is 1a. 2x is 0, x will also be 0 here. So b times 1 will be b, and then c times 1 squared will be 1. So c times 1 will also be 1. So we have 5 is equals to a plus b plus c. Okay. So from there, we are going to get what? This equation. And we know that b is already minus 2, c is equals to 3. So we have 5 is equals to what? 1a minus what? 2 plus 3 plus 3. Okay. So 3 minus 2 will be 1. And then when we do a change of subject, or 1 goes to the other side, will give us a 4. Okay, so a should be equal to 5 minus 1, which will be equal to what? Which equals to 4. Okay, so the value of a is also equal to 4. So like we are saying, this is one approach to doing this. Okay, good. Now, after we found that a, b, and c, we can then go and replace in the main, okay, in the main expression or equation there. Okay, so that we can get what? Our partial terms. Now, I think I'll take your questions at this point. So let me have the first question. Angelio, let me take your question.
Yes, sir. Sir, please can you hear me?
I can hear you. Go ahead.
Sir, please. When we are expanding the a over at the top, the very top, yes, a over x plus 1 plus
Yes.
b over x plus 1 squared.
Yes.
The question says that 11x squared plus 14x plus 5 all over x plus 1 squared. You see,
Yes.
when we are doing let's take it for instance, we have x plus 1 squared and we are expanding. It means we should write the same equation 2 times.
Yes,
But I
that's
don't
what.
understand. Yes, I don't understand. Yeah. So I was expecting at where you've written the a over s plus 1 plus b over s plus 1.
Yeah.
I was expecting you not to bring the square under the s plus 1. So the square that is there, that's what I don't understand, because we have expanded it, but still there's a square over there.
I get your point, but that is the rule. Are we okay?
Okay, sir. So whenever you expand and there's a square, yes, so you have to bring the square.
Yes. So when it says a repeated root, a repeated, let's say, denominator, first express it in the linear form and then express it in the repeated form.
Okay. Thank you, sir.
You're welcome. Yes. Okay, there's another hand up. Kadil Ibrahim. Kadil.
Sir,
Yes.
sir. I just want to add up the question the guy just asked.
Yes.
It's plus c into bracket s plus 1 all square. Can you also split it, that one?
No need to split it. I've given you a rule for repeated factors. So use that rule.
Okay, okay, sir.
Good.
Thank you.
Any other question? Okay. So which also means that when I give you a repeated factor, okay, like x raised to the power 3, just make use of the rules, no dodging around. So assuming this was x raised to the power 3, okay, then it is going to be So it means this time you have 4 terms. This one 3 times, and then this one. So it's going to be a plus b plus c plus d. So for the a, you are going to have a over x plus 1. B will be x plus 2, x plus 1 squared. D will be, if you like, c will be, okay, over what? X plus 1, x plus 1 what? Cube. I hope you are following. So that is the rule you are going to make use of. So once I give you the factor, just make use of the rule. Okay. So now we want to move on to an entirely different case altogether. Today our time is fast spent, but it's not. Yes. So for the third case, I prefer for us to look at where you have a quadratic denominator. Okay. So for example, let's take a let me see if I can get, yes. Now, before I look at that, plus 4 over x squared, let's have x cubed minus 4x, okay, x cubed minus 4x. Now, this expression here, I'm intentionally writing it like this because it can also be re-expressed as 2x squared minus x plus 4, okay, over x into bracket x squared, okay, minus 4, right? So maybe in exams or in assignment, I'll be giving you this, but it does not take away the fact that this expression here is still the same as this. So when we get to integration and we have to integrate, okay, and you see an expression like this, you should be able to re-express it in the partial fraction form like that. Okay, so we are going to pick the second form and then use the rules to express it. Now, if I give you a quadratic denominator like this is what you do. You see, the first term here is linear. This is x. X is linear. So you have a and then you have b, because now you have 2 terms. Now take note, the square here is not, okay, after the bracket. It is on the x. That is why we say quadratic. So it is a special case. It's not the same as x minus 4 all squared. So this a will have the first term, which is x, and the b will have the second term, which is what? X squared minus 4. Now, you agree with me that because it is quadratic in nature, okay, we are supposed to have had 2 expansion, because if the degree is 2, then there should be 2 terms, okay? But because this time it is quadratic, what you rather do is you are going to have bx plus a c. So both the b and the c will share the same common denominator, okay? And then you have to bring the variable c at x attached to what? The b. So that is the rule. You express the linear term as linear, but the quadratic term will always come with a bx plus c over that quadratic term. Anytime you are expressing a quadratic term like that, you're going to have, if it is cx plus d or dx plus e, it will always come in that form. So you take note of that rule. Okay, so then let's solve this. I'm going to rewrite it at the top for us to solve. So let's rewrite it here. We have we are expressing 2x squared 2x squared minus x plus 4 over what? Over x times x squared minus 4. Like we are saying, the rule is we have a over what? A over x, okay, plus we have bx plus c over what? X squared, okay, minus 4. So I'm going to clean the rest. Okay, then we follow our principles. So this is going to give us, we find the LCM as usual. So we have x, okay, times s squared minus 4. Okay, then this will give us what? A, x will go here how many times? This number of times. So this times what? S squared minus 4. Then we have plus, we have bx plus c, okay, which is the numerator. So in this case, put it in brackets, okay? Put it in brackets for the quadratic. Just put it in brackets. Okay. Then the denominator here, which is x squared minus 4, goes into this x times. So we bring the x by 8. Okay, good. Then once we've gotten to this stage, the next question is how or what figures do I select? Okay, that will be the next question to ask yourself. So first, write the expression. We know denominators are the same, so numerators are also going to be what? The same. So we have 2x squared minus x 4 is equal to what? A times x squared minus 4 plus b x plus c times x. Okay, like you can see over here. Now, I prefer going with this very simple method where we use elimination, okay? Unless otherwise, where probably elimination is not going to help. Then you can expand your terms and then try to compare terms to come to a conclusion. Okay, so in this context, when we look carefully, if we want to eliminate or want to find, if we wish to find, let's say a, all we need to do is to select maybe x equals to what? S equals to 0. Because if we select x equals to 0, this x will go to what? Will go to 0, which means that the whole term here times 0 will be 0. Then we can find our a. So this will be 2 into brackets 0 squared will be 0 minus 0 plus 4 equals to a times what? Minus 4. Okay, plus this whole term here is 0, like we said. So on the right side, we are left with what? 4. And on the left side, we have negative 4a. which implies that A is equal to what? A equals to minus 1. Okay, very well. Okay, then what's next? We're going to select, looking at this, if we let x be equal to 2, okay? If we make s equals to 2, then we'll be left with B and C to contend with, okay? Good. Now, we can let x be equal to 2. So making x equals to 2, we'll be left with, left hand will be what? Will be 2 times 2 squared, which will be 4. Then we have minus what? Minus 2 plus 4. Okay. Equals to, we have A times 2 squared is 4. So 4 minus 4 will be 0. So A is gone. Then B times 2 is going to be what? 2B. Okay. Then plus C. So that will be what? So here we have 2B plus C. Okay, times what? Times 2. So on the right hand, we have 8 minus 2, which is what? 6 plus 4, which is 10. On the left hand, we have 4B. Okay, 4B plus 2C. Okay, which is an expression would have to find possibly C or D. Okay. Now I can see some hands coming up. Let me take Isaac Nyanina. Yes, Isaac.
Sir,
Yes.
yeah, please, taking at the second step, which x is equals to 2.
Yes.
When we said x is equal to 2, we get 2 bracket open 4, but it's equal to 2 plus 4 is equal to the, when you set the x to 2 and you get something like 2b plus c, and then bracket open, bracket closed, the x squared there, is it going, you put 2 there, so I don't understand. But the x is square, so if you are squaring x, it will be something like 4. So I don't understand why it's 2.
On the original
Yes,
equation, this is x, it's not square. This is just an arrow, it's not square. It's not square, it's an arrow.
it's not square. Okay,
Mm.
that's why I got confused. All right, thank you, sir.
Yes, Angelo, let me take your question.
Okay, let me do it. So when we found when we give x equal to 0,
Yeah.
on the upper equation you have 2x squared minus x plus 4.
Yes.
And when we give x equal to 0, in the bracket you have 2 into bracket 0, and the equation is saying 2x squared. So I was asking, the 2x squared, the x, it is squared, right? So like I don't get that side.
Yeah, 0 squared is what?
0.
Yes.
0. Okay.
Okay, let me take another question. You see, some of the questions, just think through carefully before you ask the question. Or we don't have time. Michael Ashiagbo. Ashiago, I've unmuted you. Okay, let's go to the next person. Alex Agba.
Sir, please. We made the other side 0, which is the x.
Yeah.
Sir, please, can you hear me?
Yeah, I can hear you.
Okay. We made the other, on the first step, we made it 0. So
Yeah.
why would we make the other side to 0 instead of being 2? So please, that's my question.
Okay.
Yeah.
I don't know whether you were following in class, but the steps are as outlined. After you find one, okay, unknown constant, you select another value of x. So we finish with x equals to 0. Now we are selecting another value of x, which is what? X equals to what? 2, which will help us to eliminate what? To eliminate a, okay? So that we can get an expression in terms of b and c. However, even putting x equals to 2, we can see that we have an expression in terms of b and c. But how do we find b and c? Okay, so this is why I said, when elimination fails to work, and this time around, what you do is you have to expand the terms, okay? So we are going to expand the terms and then compare terms. So I'm going to expand the right-hand side for this particular equation. So we can compare terms because we said they are the same. So on the right-hand side, when I expand, this is what I'm going to get. I'm expanding it like this, okay? A times this, a times that, then I simplify. So I'm going to have ax squared minus 4a plus bx squared, okay, bx squared, bx squared means this and this times this, and then finally c times this, so plus what? Cx, okay, good. So we are going to group like terms. This will give us ax squared plus bx squared. They all have x squared, okay? And that's why we're grouping them like that. Then minus, no, the next term will be the x term, so plus cx minus what? 4a. So we just rearrange them, grouping like terms. So this side, if I factorize s squared out, I'll get a plus b times what? X raised to the power 2. Then this side will give me plus cx minus what? 4a. So this is the expansion for the right side here. This is the right side expansion. I've expanded and rearranged group like terms and done rearrangement. So if that is the case, then what we are saying is, you see, all along, what we are saying here is the left hand side is equal to the right hand side. So if indeed the left hand side is equal to the right hand side, then it means that a plus b should also be equal to 2, because the coefficient of s squared here should be equal to the coefficient of x squared on the left hand. Which is the first statement of fact. So which means that a plus b should be equal to what? Should be equal to 2. Please listen attentively. Listen attentively. Don't just a plus b is equal to 2. And you see, we have cx here. This is only x. This is minus x. So the coefficient of x here, which is c plus c, should be equal to the coefficient of this x here, which is minus c. So we have the expression c is equals to minus what? 1. Okay, good. Then the third expression you can have is, you see the constant here, which is minus 4a, is also the constant here. So from the third expression, we have what? Negative 4a is equals to what? Equals to 4. It's equals to the constant there, 4. Right? Yes. But when you look at this third equation here, we don't need it again because we've already found the value of a. In any case, if you hadn't found the value of a, and then you solve a from this expression, dividing both sides by negative 4 will give you a is equals to minus 1, which we've already found here. So this is a redundant equation. We don't need it in our calculation again. What we now want to find is c and b. Good. And from our expression too, we know that c is also negative 1. So c is negative 1, right? And then from this equation, we know a is negative 1. So if a is negative 1, then it means we have the expression minus 1 plus b, minus 1 plus b is equals to what? Is equals to 2. Okay, so which means that this will cross to the other side, which will become what? Positive 1, right? So we are going to get b is going to be equal to what? B is equals to 3. Okay, so we are going to get our b, which is equals to 3. Now this gives us just cross-checking something. So this is this, that is this, a negative 4. Okay, so we got all our factors, which is a is minus 1, b is minus 1, b is equals to 3. Now we want to put it back into our expression. So once we've obtained a, b, let me write b here. B is 3. The c is minus 1. Okay, we'll be putting it back into the main expression to get the partial fraction. So now let me take your questions. Once again, I have Michael and Isaac here. So let me take Isaac first. Yes, Isaac, let me take your question. Yes.
Yeah, sir, please. Where we have the a x squared minus 4a plus bs squared plus c x.
Yes.
And then we group them.
Yes.
So that is where I'm a little bit confused.
You were not following. You were in a hurry to ask questions. So
No. I was just following. That's why I got confused. I was just on my start.
a times s squared will give you as squared. A times 4 will give you minus 4a. Bx times x is bx squared. And then c times x will give you cx. Are we okay now?
Yes, sir.
Okay, let me take the next question. Michael.
Hello, sir.
Yes.
Please, I'm a little bit confused about where you get x equal to 0, and then the other hand is x equal to 2. I'm a little bit confused.
X equals to 0. I keep repeating this thing over and over. I think by now you should understand the concept. You select the X value intentionally to what? Eliminate one of the variables.
All right.
Yes, that is the whole concept. So here, because there is X outside,
Yeah.
you intentionally select X equals to 0 so as
Okay.
to eliminate B and C. Then you
Okay.
can solve for A.
Okay.
So it's an intentional decision. But what I'm trying to emphasize by this S equals to 2 here is, it is
Yeah.
not always the case that when you even select an X to eliminate, you entirely eliminate all the variables. So in this demonstration, you see we have an equation, okay, in terms of B and C. Now what's next? You can't find any S value which can eliminate C for you to get B. So the best approach is to expand the term on the right hand, and then you compare the coefficients to get new expressions which we can use to find your B and C.
Okay.
Yeah. Yeah, let me take one more question. Okay, I think it appears to be very clear to everyone. Okay. So in that case, let's move on to the third type of, no, the fourth, okay, type of expression. So Peter has now raised his hand. Yes, Peter.
Sir, please stand. Lecture is in.
Your lecturer is in.
Yes, sir.
Okay, well noted, Peter. Yeah, so we'll end at this point, okay, and probably we'll find some 1 hour within the week and then meet. So just expect me to post another link for your class in the next meeting. Please don't log off yet. I want to take my attendance before you leave. So let me quickly take my attendance briefly. Okay. So yeah, so I have 132 people in class. Those of you who are using numbers for your ID or iPhone and this thing, just type your name for me in the chat page. Else, once I escape your name, that is it, means you were not in class. So if you logged in with some numbers or a name that is not your actual name, just go to the chat and type your name for me. Please don't, when I'm logging off, before you do that. Do that right away. Type your name for me so you can attend your next class. So something like Victor Visa. I mean, that is not your name. Zoom user is not your name. Infinix 54 is not your name. So all of you, I expect you to type your names right away for me. But I've already delayed. I've taken part of your time. Okay. Okay. I think I saw somebody post on the page He's not done writing. Don't worry. I'll send the slides to you, so you don't have to worry yourself. Okay, so on that note, I believe everybody has sent a name. On that note, we'll end today's class here. Thank you all for coming and for your patience. I'm sure next time we will not repeat the mistakes we did today. See you all in the next class. Bye-bye.